In our last video for section 4.8, we're going to discuss something called bearing. So you've probably all heard we're going to catch our bearing. I'm sure you've heard this word before, but essentially when we're discussing bearing, we're talking about the direction we're headed. And so I want us to all think first of all about a compass. So we have north, east, south, and west. You've maybe heard never eat soggy waffles. That's one way to remember this. But what bearing says is I'm going to take some angle, and we're always rotating from north, and we're going to go clockwise. So this angle here, theta, I've rotated past 90 degrees, so that would be 90. So this maybe we could say, but it's not quite 180, so we could say this is maybe, I don't know, 140 degrees or something like that. So that would be an example of a bearing of 140 degrees. So what I would say is if I'm here, and I told you I was bearing 140, I'm saying I'm going in this direction. So I'm sort of headed southeast, right? So as an example, if I am bearing 140 degrees, that means I'm sort of going southeast here. So we'll keep things a little bit more straightforward in this first section we see bearing. This will come back later on. But let's just do an example to illustrate what bearing is and kind of how we can do some problems with it. So most of the time bearing refers either to ships or planes, so anything that navigates. So let's go with a ship here. Let's say a ship leaves a port at a speed of 20 knots. Now, knot is a unit of measurement that stands for nautical miles per hour, and 1 nautical mile is defined to be 1/60th of a minute of a rotation around the world, which is a little bit ambiguous. So nautical mile is 1.151 regular miles. But our answer we can just leave in nautical miles. We won't worry too much about that. Okay, so we have our ship. It leaves port at 20 knots, and we're going to say it's bearing 258 degrees. And so the question is, how far north or maybe south and east or maybe west is the ship from port after 1 hour? How far is it from port after 1 hour? Okay, so let's start off just by drawing. So let's say we have our port here. I'm going to say this is north, and if I rotate around 258, well, this would be 90, that's 180, and that would be 270, so that's a little bit too far. So we're going to say that we've gone, maybe here is about 258 degrees. I'll draw the rest of my compass here. So we're heading sort of in a southwestern direction, and after 1 mile, the ship is, after 1 hour, the ship is actually 20 nautical miles away. So here's the diagram. It's gone 20 nautical miles in a straight line, bearing 258 degrees from port. Our question, though, is how far, so it looks like it's going south, and also how far west have we gone? And so here is our setup. Now we're going to basically do the exact same process that we've done already in this class. We're going to figure out the value of essentially this triangle. Except things are going to be a little bit switched. So rather than measuring from so usually we think of this as the x-axis and this is the y. Since we're measuring from north, I'm going to actually flip this and we're going to just assume for our purposes that this is the x-axis and this is the y. So if we were to redraw this sketch, we could say x and y, and then this is the north direction. Now, rather than going counterclockwise, we can just say let's go clockwise instead. So I'm going to go 258 degrees over here. And then we'll just kind of have to flip back when we're done. And all this comes down to is, so cosine of 258 degrees is x over r. So the x will give this distance here, and then sine of 258 will give me y over r, which is essentially this distance, right? And it's also going to be important to keep in mind what y and x are. So notice that if we were kind of relating this back to the compass, we have north here. Up here would be east, south, and then west. And so then once we've found our values for x and y, we can actually finish the problem up. Or we can answer the problem. So r is actually 20. The radius is that distance 20. And so all I end up having to do is x equals 20 times cosine of 258, and y equals 20 times sine of 258. Okay, another way to remember this, if you'd rather think about it this way, is that x, in this case, actually gives you north and south. So just notice that x is north or south. If it's a positive number, it'll be north. If it's negative, it'll be south. And y in this case is east and west. Same thing, positive y will give me east, negative y will give me west. So if you'd rather not flip these coordinates around like I did here, you could just remember that x is now going to be north because that's where we're rotating from. We always rotate from x or from north, and then east and west will be y. But let's go ahead and see what we get, and then that'll be the answer. So 20 times cosine of 258. Make sure you are in degrees mode. I get negative 4 point, let's say 2. Oops. So I get, so let me go ahead and undo real quick. Negative 4.2 nautical miles. So the negative in this case means I'm south, which is correct based on our diagram. So I have negative 4.2 here. And then if we're doing sine, let's just go ahead and do 20 sine of 258. And I end up with negative 19.6 roughly. So rather than saying the boat is 20 nautical miles bearing 258, we could now say the boat is 4.2 nautical miles south and 19.6 nautical miles west of port. So once again, these negatives represent, in this case, this was west and then this one was south. If we had gotten positives, we'd actually be on this side of things, but the negatives tell us which direction we're going. And that's the extent to which we will do bearing problems so far. Later on, like I said, we will see some more complicated type questions. This can also be applied, I've seen this applied with firefighting out in the forest. They'll say, you don't want to say that's fire is northeast of here, you want to get an exact bearing. So we'll be seeing some different problems involving that later on.